Everywhere we look around, there are patterns. But what do we know about patterns? We know they repeat. Some have a start and an end, and some don't. They can increase and decrease. And often, when we work with numbers, we see that patterns will form. What is the same about all these patterns? They have the same number of repeats. And these repeats are called units. When units repeat one after another, it's called a sequence. And a sequence is made up of units repeating in iterations. But what if we've wanted to find out the total number of A's and B's after 63 iterations? How about 123 or 10,023? Drawing the pattern would take too much time, so let's try to show it in a different way. This chart shows iterations and their total number of A's and B's. With one iteration, there are 2 A's and 1 B. With 2 iterations, there are 4 A's and 2 B's. 3 iterations have 6 A's and 3 B's, and so on. Let's look at the relationship between the numbers in the B column. When we have 2 iterations, it increases by 1. When we have 3 iterations, it also increases by 1. The pattern here is the B's increase by 1. With the numbers in the A column, we can see each time they are increasing by 2. The pattern here is they're increasing by 2. To write out 63 iterations would take a long time. Can we look at it another way? For 1 iteration, there are 2 A's. For 2, there are 4, and so on. The number of A's is equal to the iterations times 2. The number of B's is equal to the iterations times 1. Or A equals iterations times 2, B equals iterations times 1. If we shorten iterations to I, we can write this out as an equation. And to make it easier, we know that I times 1 is just 1. Now let's check our formula. 2 times 2 is 4. 4 plus 2 is 6. 9 times 2 is 18. 18 plus 9 is 27. Now what would the answer be for 63 iterations?